So for number 5, we want to prove these statements about a circle, and we're going to use proof by contradiction. So proof by contradiction goes like this. You assume not P, then you develop the proof, show that it leads to some proposition Q, show that it leads to not Q, and so you're going to have Q and not Q, which is a contradiction. So your assumption must have been false, and therefore P is true. So for A, we're given that a circle has center 2, 4. So we're going to say assume that a circle has center 2, 4. And if it has center 2, 4, if and only if the equation for the circle is x minus 2 squared plus y minus 4 squared is equal to r squared for x, y, and r belonging, I should do actually little r, belonging to the set of real numbers. So that's what we're going to assume for all of these. And now for item A, we want to prove that -1, 5 and 5, 1 are not both on the circle. So we're going to assume the opposite, assume not that. So we're going to say assume that the point -1, 5 and 5, 1 are both on the circle. So what we're going to do here is plug in the first point in the equation, right? So we have here -1. I'm going to plug that in for x. So I have that -1 minus 2 squared plus, for y, I have 5. 5 minus 4 squared. This is equal to r squared. And so -1 minus 2, it's going to be minus 3 squared. So that's going to be 9 plus 5 minus 4 is 1 squared. 9 plus 1 is equal to r squared. And therefore, r is equal to root 10. Okay, so now we're going to plug in the second point, 5, 1, right? And now we're going to have 5 minus 2 squared plus, that's going to be 1 minus 4 squared is equal to r squared. So 5 minus 2, 3 squared, 9 plus 1 minus 4 minus 3 squared is 9 is equal to r squared. And therefore, 18 is equal to r squared. And so r is equal to root 18. So now I'm going to say, okay, r is root 10 and r is equal to root 18, which is a contradiction. And so we have shown that a contradiction has happened, and therefore our conclusion is that our assumption was wrong. Therefore, -1, 5 and 5, 1 are not both on the circle. Okay, and that is it for item A. We have proved it by contradiction. So I'm going to leave this assume that a circle has a center because it's going to be valid for, we're going to use that assumption for all of our items here. And so now we're going to do item B, which is if the radius is less than 5, then the circle does not intersect the line y is equal to x minus 6. So we're going to assume the opposite. Let me just zoom in. So for B, we're going to assume that the radius is less than 5 and the circle intersects the line. So that would be the opposite. So assume that r is less than 5 and the circle intersects y is equal to x minus 6. Right. So from here we can gather two things. Therefore, r squared is going to be less than 25 and y is going to be equal to x minus 6. Okay, so once we are here, let's just plug this into the equation for our circle. So we have that x minus 2 squared plus, wherever I have y, I'm just going to put x minus 6. So it's going to be plus x minus 6 minus 4 squared. And if r is less than 25, if r squared is less than 25, then since this whole thing is equal to r squared, this whole thing is going to be less than 25. Okay, so what I'm going to have here is that, let's see, that's going to be x squared minus 4x plus 4 plus, this is going to be x minus 10 squared, so it's going to be, so plus x squared minus 20x plus, it's going to be 100 is less than 25. And so I'm just going to simplify this. I'm going to get 2x squared minus 4 minus 20 minus 24x. And then let's see, I have plus 104 is less than 25. And so I have a 2x squared minus 24x. Let's see, that is 104 minus 25, which gives us plus 79 is less than 0. So what we're going to do here is we're going to use the quadratic formula. And so we're going to say by the quadratic formula, you do want to find out what x1 and x2, what they are. So x is going to be equal to minus b, so that's 24, plus or minus b square root of b squared, so that's going to be 24 minus 24 squared minus 4 times 2 times 79 divided by 2a, so divided by 4. And so I have here that x is going to be 24 plus or minus, let's see, 24 squared minus 4 times 2 times 79. That's going to be root of minus 56 over 4. And therefore, I have here that x, let's see, 56. If I factor out a 2, I'm going to have here that x is going to be equal to 24 plus or minus, that is going to be square root of negative 14. I'm going to put a 2 outside, divided by 4, and therefore x is going to be equal to, I'm going to divide everything by 2, so it's going to be 12 plus or minus root of 14i divided by 2, which is a contradiction since x belongs to the real numbers, right? So we have shown that x is imaginary and x is real, and that is a contradiction. Therefore, our assumption must have been wrong, right? And so we say, therefore, if r is less than 5, then the circle does not intersect y, the line y is equal to x minus 6. Okay, so we have shown that a contradiction has happened here, and therefore our assumption is wrong. And now, lastly, we are going to do item C. Let me just erase all of this stuff. So for C, we're going to prove that if 0, 3 is not inside the circle, then 3, 1 is not inside the circle. And we're also going to do it by contradiction. So here is the form if P, then Q. And whenever we have a conditional statement, if P, then Q, if we want to falsify this, not P and Q is equal to P and not Q. So that's what we're going to do. We're going to assume P and not Q. So assume 0, 3 is not inside the circle, and assume not Q. And and let 3, 1 be, so not inside means inside, be inside the circle. Okay, so we've said P and not Q, which is the opposite of the conditional. So, so if 0, 3 is not inside the circle, then 0, 3 is on or outside the circle. Thus, the radius is less than or equal to the distance between center 2, 4 and 0, 3. And that just means, right, if it's on or outside, then the radius is either equal to or smaller than this distance. So the distance is going to be equal to, let's see, the square root of, that's going to be 0 minus 2 squared plus 3 minus 4 squared, 3 minus 4 squared, which is going to be equal to the square root of, let's see, minus 2 squared is 4, plus minus 1 squared is 5, and so the distance is equal to root 5. And so we can say here, therefore, that the radius is less than or equal to root 5. Okay, so that's one of the things. But if 3, 1 is inside the circle, if 3, 1 is inside the circle, is inside the circle, then distance between 2, 4 and 3, 1 is less than the radius. So let's see what this distance is. Therefore, D, actually, let me put some notation. So I'm going to put, no, we'll just leave it at that. So this distance here is going to be equal to square root of, let's see, that's going to be 3, let me see if I did this wrong, 0, 3, 3, 1. Okay, no, that's right. So 3 minus 2 is going to be, so 3 minus 2 squared plus 1 minus 4, 1 minus 4 squared. And so we're going to have here that this is 3 minus 2 squared is 1 plus 1 minus 4, negative 3 squared is plus 9, which is equal to root 10. And so what do we mean here is then the distance is less than the radius, so that we have that, therefore, that root 10 is less than radius. So we have that radius is less than or equal to 5, and root 10 is going to be less than, root 5. Yeah, and root 10 is going to be less than the radius, which is a contradiction. Yeah, so we've shown that, hey, the idea of the distance doesn't match up, right? Because if 0, 3 is on or outside, then the distance must be greater than or equal to the radius. And if 3, 1 is inside, then the distance must be less than the radius, but it doesn't add up. Therefore, our assumption must have been wrong. So therefore, if 0, 3 is not inside, then 3, 1 is not inside the circle. And that is it for problem 5.